graphs to the parent function. So the graph of y equals 1/3 times 1/2 to the x is a blank blank of the graph of y equals 1/2 to the x. It's a vertical shrink. Why is it a shrink?
Because A is less than 1. Because absolute value is 1.
Because the absolute value of A is less than 1. What is A? 1/3. What's the absolute value of 1/3? 1/3, and that is less than 1. The second one says the graph of y equals negative 1/3 times 1/2 to the x is a blank blank with a blank on the x-axis.
Vertical shrink with a reflection.
Absolutely. It's still a vertical shrink. What is the absolute value of A in this case? 1/3. And because A is negative, it's a reflection. Are we good? We understand where all that's coming from? Great. Now, the last part of this is the exponential decay model. When would you find decay?
When stuff is decreasing in value.
Exactly, when stuff is decreasing in value. That's absolutely right. For instance, let's say a car. Give me a car.
Ferrari.
Give me another car.
Lamborghini.
A Prius. Okay? That's a Honda, right? Toyota Prius. Toyota Prius. Nice, classy, environmentally friendly car. You can get one on the lot for about $20,000. Okay? Now, as soon as I take that car home, after I paid the dealer $20,000, it's going to be worth about $15,000 the next day. Because now it is a used car. After a year, it'll be worth probably close to $12,000. After 3 years, 8. After 10 years, 1 if you're lucky.
Just for the metal on the car.
Okay? Unless you put some sweet rims on it, you know, or something. But, okay? That is exponential decay. When it decreases by a certain percentage.
What if you buy like a new Camaro Z28, right? And then it decays whenever you drive it off the lot. But if you wait like 20 years, it'll start going up in value.
Exactly. But it has to decrease before it will increase. Almost everything that you buy depreciates in value except a house. If you take care of your house and you live in it well, then the value of the house is going to increase. Unless you trash it and let your dog eat up all the walls and scratch and stuff. And your kids punch the wall in because they get angry and you don't fix it. Okay? So, most houses will appreciate most everything else that you buy depreciates. So let's look at the model. The formula that we use for decay is y equals A times the quantity of 1 minus R to the t power. What is the difference in this one than yesterday's?
Plus R.
It's subtracting instead of adding the rate. What does the A stand for? The initial amount. What does the R stand for? The percent, which we change to a decimal. And what does T stand for? The time in years. So let's look at this example. You buy a computer for $3,000. It depreciates at the rate of $20,000 per year. Find the value of the computer for the given year. After 1 year, what is my formula going to be? Y equals 3,000 times the quantity of 1 minus 0.2 raised to the first power. If you have your calculator, type that in, please. And what is the amount? $2,400. Let's find out the value after 3 years. Y equals 3,000 times the quantity of 1 minus 0.2 raised to what power? Raised to the third power. What? I still can't hear you. 1536. So after 3 years, it loses about half its value. And after 5 years, y equals 3,000 times 1 minus 0.2 raised to the what power? Fifth power, which is what?
$983.04.
$983.04. Any questions on figuring out the decay?